We're going to go through a tutorial on how to set up and solve linear equations with MATLAB. So we're all familiar with expressions like 3x minus 9 equals 0. We can solve those exactly, x equals 3, and those aren't difficult. But let's say we have 3, 10, a million of these equations and we want to be able to solve them. We might need to do that numerically. Or for some simple problems we can also come up with symbolic answers. So we're going to go over some of the functions in MATLAB to be able to set up and solve some of these systems. So let's go with a 2 variable and 2 equation problem. Let's go 3 times x minus 9 times y equals negative 42, and then 2 times x plus 4 times y equals 2. Okay, so let's set that up and solve it in MATLAB. So I'll go ahead and open up MATLAB and then just do this from the command prompt. And then I'll give you an example that you can try, and then we'll complete and pause, and then we'll complete this video. Okay, so what I'll do is just bring my MATLAB window over here to the side. Now part of it is that, let me go ahead and just close this other script. Okay, I'll make this just a little bit bigger. Okay, so what we'll do is, first of all, just go ahead and enter in these equations in matrix form. So I'll just say that A is going to be equal to 3, negative 9. If I want to start a new row, then I put a semicolon there, and then 2 and 4. Okay, so there is an A matrix, and then a B vector. This is going to be the right hand side of that equation. It's going to be negative 42, start a new row, and 2. Okay, so there's the A and B matrices. So I'm basically just putting this into an alternate form here, which is 3, negative 9, 2, and 4 times x and y equals negative 42 and 2. And then to be able to solve this, I'll just do x and y equals, this is matrix A, and vector B is just going to be A inverse times B. Okay, so that'll give me the solution to this equation. So if I come back into MATLAB, I have my A and B matrices. So what I can do now is just say that Z, let's just call this Z, and I'll do A to the negative 1 times B. Okay, so that gives me the solution. I can also do Z equals inverse A times B, and that gives me the same solution. So let's say that we didn't know A, B, or these coefficients in here. We can also do this symbolically as well. So let me go ahead and clear the screen with CLC, and let me do symbolic symbols, and I'll do A, B, C, and D. Okay, so it came up with a few symbolic symbols. Actually, let me go ahead and clear all the variables before I do that. Okay, then I can just hit the up arrow and execute that command again, just so my workspace is clear. I'm not conflicting with any other variables that were typed previously. Okay, and then I can do maybe a matrix M. It's going to be A, B, C, and D. Okay, so those are symbolic, and then if I do the inverse of M, then I get this in symbolic form as well. Okay, so let's say I had the B vector equals, let's say not B vector now, let's just call it something else. I'll just call it the right hand side equals 2 and negative 1. Okay, and then my solution Z then is going to be inverse of M times right hand side. Okay, and then it shows it in symbolic form. Okay, so we can either do this in exact or symbolic form. Let's go ahead and try just another example in MATLAB, and I'll let you try it first. So let's go ahead and do another set of equations. In this case, we'll add another variable Z, and so if you want to, just go ahead and try this one. It'll be x minus 2y minus z equals 6. And then another equation, which will be 2x plus 2y equals z plus 1. And then a third equation, which is going to be 2 times z minus 1 equals y plus x. Okay, so the first thing that we'll need to do is just put this into matrix form so that we can solve it in MATLAB. Okay, and we'll have our matrix coefficients here and then the right hand side here. Okay, so any variables, we'll just go ahead and move those to the left hand side, and any constants, we'll move those to the right hand side. Okay, so if we put this into matrix form, we have 1 here, because that's 1 times x, 2 times y, negative 1 times z, and then 6 is on the right hand side. And so let's just go ahead and complete that for the other ones as well. So we'll have 2, actually that'll be negative 1, negative 1, 2, and 1. Okay, so go ahead and try to put this into MATLAB and go ahead and find a solution to x, y, and z. Go ahead and pause the video and then start again when you're ready. Okay, so let's go through this final example. What we'll do is go ahead and just clear all, if you have any of those left, variables left, and we'll go CLC as well just to clear the screen. And I'll say that my A matrix is going to be 1, negative 2, negative 1, start a new row with a semicolon, 2, 1, negative 1, and then negative 1, negative 1, 2. Okay, and if I put a semicolon after it, it suppresses the output, so I don't see the result of that. But if I take away the semicolon, then it'll show me my A matrix, and I can verify that it's correct. So B is going to be 6, 1, and 1. Okay, and then let's go ahead and compute our solution, which is going to be the inverse of A times B. Okay, so there's our solution, 3, negative 2, and 1. Okay, so that's how you solve linear equations in MATLAB. Our next video is going to be about how to solve nonlinear equations in MATLAB.